Listen my dear, so before we are going to swing equation, it is very important to find the concept of inertia constant, because a question may be directly asked from this inertia constant also. No? You find out the inertia constant, like type of question may be asked. It is already asked. If you refer previous A examination questions, you will definitely find a question like this. What is the inertia constant and all? Okay. So consider an alternator. The input is nothing but, my dear, the mechanical energy, right? Mechanically rotating energy, right? That is nothing but half J into omega Sm square, where J is nothing but, my dear, moment of inertia. Correct now? Moment of inertia. And omega Sm, it is nothing but, my dear, mechanical angular velocity. In radian per second. Okay, so this side is nothing but the mechanical term, and see this side electrical energy, and we have the electrical energy basic equation for the wound rotor type alternator. Wound rotor type alternator. If you are dealing with a salient power alternator, there will be a salient power also. No? Due to saliency, there will be some power also. But for wound rotor type, for the simplicity of explanation, so power P is equal to EV divided by X into sine delta. So why I took delta, na, sine delta or delta earlier? Na? Did you get the idea? This is nothing but the rotor angle. So unless you know the rotor angle, if I directly took this equation or took this concept, means you will be confused. What is meant by rotor angle del? You will get confused. So P is equal to EV divided by X into sine delta is the output of the alternator. These things you already know. So input side is a mechanical quantity, output side is an electrical quantity. It is not that much fair now, because if you want everything is in electrical, that will be very easy for an electrical engineer. For a mechanical engineer, they will convert that electrical to mechanical and they will analyze. For electrical engineer, we have to convert this to electrical quantity and compare to two electrical quantities. Then only our as an electrical engineer, we will find very easy when everything will be in electrical quantity. So we have to convert this input side to electrical. Okay. For that, basic equation we know that one. Theta electrical equal to P by 2 into theta mechanical. Is that clear, my dear? So what will be d theta e divided by dt, P by 2 into d theta m divided by dt. Theta e means electrical, theta m means mechanical degree. What is d theta by dt? I can say like it is omega s e. That is a electrical angular rate, velocity. Na? It is nothing but P by 2 into omega Sm, mechanical angular velocity. Or from this I can say that omega Sm will be equal to 2 by P into omega Sc. 2 by P into omega Sc. Okay, so substitute the omega Sm as here. We can say that kinetic energy K is equal to nothing but, my dear, half into J into what is omega S? Omega Sm, it is nothing but 2 by P into omega Se. Omega Sc the whole square. Correct na? Omega Sc the whole square. 2 into omega, not whole square, 2 by P into omega Sc the whole square. Or simply I can rearrange like this, half into J into 2 by P into omega 2 by P square into omega Sc into omega Sc. Just I rearrange this equation, my dear. 2 by P the whole square I took, 1 omega Sc I took, and 1 is beyond that, beyond the bracket. So what will be this J into this term, my dear, this J into 2 by P the whole square into omega S E equal to, I can represent like simply M into omega Se, half into M into omega Se, which is nothing but the kinetic energy K, where M is called inertia constant. M is called inertia constant. Or I can say that this is one form of representing the kinetic energy. There is another form also representing the kinetic energy, is nothing but, my dear, kinetic energy K is equal to G into H. There is another equation for representing the kinetic energy. Here this H is called the inertia constant, another type of inertia constant, my dear. Another type of inertia constant. I will tell you on a practical example. Suppose we are moving in a bus now. We are moving in a bus. Suddenly the bus stops, means we will move forward. So by analyzing our motion, bus motion, the mass of the machine, the mass of the human body, there will be some inertia constant. No? That is one example. Suddenly a rotor is running. If you switch off the supply, the rotors again it will run for few seconds or few minutes due to inertia. So while analyzing its angular velocity, its mass, now everything if you analyze, you will get another type of inertia constant. So situation to situation, inertia constant will vary. So if you are dealing with one type of kinetic energy, you got 1 m as inertia constant. If you are dealing with another type of kinetic energy, definitely you can give K is equal to Gs as another equation for inertia constant. This is another inertia constant. What will be the difference between this m and this h? I will discuss later. Okay, just wait. So this K is equal to G into H. This G is nothing but, my dear, base MVA. Base MVA or rating, simply voltage into current, that is the rating. So rating of the machine into H will give you the value of what? In another kinetic energy. So LHS of this and LHS of this will be what? Same. So if we combine it together, I can say that half m into omega s is equal to G into S. From this m is equal to 2gh divided by omega se, or I can say that 2gh divided by omega can be represented like 2 pi into f. 2 and 2 get cancelled. Simply m is equal to gh divided by pi f. A very, very important relation, my dear. The moment of inertia m is equal to what? Gh divided by pi f. Gh divided by pi f. Okay, and now I am going to tell you what is the difference between this m and this h. Both are inertia constant now. Array sir, you are saying both are inertia constant. Then why you are saying it is two equations? I will tell you now what is the difference. So this equation are very, very, very important relation. M is equal to Gh divided by pi f. Directly you can expect this equation. Directly they will give you some values and you can find the moment of inertia. So our moment of inertia, what we should take? If the questionnaire asks simply moment of inertia, means which moment of inertia we have to find, H or M. We have to focus that. Okay, I will tell you that also. I will tell you that also. So I am omitting this. So I am rewriting this equation again, my dear. M is equal to Gh by pi f, which is, I will tell you now. See, this M now, this M, what will be this M from now? This equation, from this equation, or simply you can say this 1 and this 2. From 1, what will be the value of M now? From 1, M will be equal to what, my dear? 2 into kinetic energy divided by omega sc, correct now? That is, what will be the unit I am going to find? I can say that kinetic energy joule is nothing but megajoule divided by radian per second, means second will go over. So megajoule second divided by radian. So that is the unit of M, megajoule second per radian. Very, very, very important. Very, very, very important. Okay, next from 2 from 2 the inertia constant H will be, what will be, how can I write like K divided by G, which is nothing but megajoule divided by MVA, correct na? Megajoule by MVA. So megajoule per MVA is the unit of H. So I can say that unit of H, megajoule per MVA. Or see, my dear, what is this energy? That is kinetic energy, or I can say that energy divided by mv is nothing but power. So energy by power is equal to what? We have power is equal to work done by time or energy by time, because work and energy both are same. So what will be energy by power? It is equal to T na? T, right? Energy by power. So T. So what will be the another unit of this? Is nothing but T. So another unit is nothing but time T, or simply seconds. Seconds. So this is also very, very important, my dear. Direct question you can expect. So how can we distinguish which moment of inertia we have to find? Which moment of inertia you have to find? You can change their heading like M or H, or simply M and H, na? M and H, that will be very fine. See, my dears, see. So from equation number 1, you got the moment of inertia M unit as megajoule second per radian. So if the questionnaire is specifying in the question that suppose the moment of inertia of an alternator is given by something megajoule per second, megajoule second per radian, some megajoule second per radian, then you should take it as M, you absorb it as M. And if some in other question, if the questioner ask if the alternator contain the moment of something, some moment of inertia of this much megajoule per MVA or seconds. Megajoule second per radian means you should take as M, megajoule divided by MVA, or megajoule per MVA, or in seconds you should absorb it as H. That's all. Otherwise your whole answer will be wrong. If you interchange, if you are really confused, in a confusion state between this H and M, my dear, you will lost. So what is the trick to find this? Whether the questionnaire is given the H or we want to find M, or whether the questionnaire given M we want to find H. Took the unit. Focus on the unit. If the unit is megajoule second per radian, blindly go for M. Otherwise you simply go for H, that's all. The other two units are, one is seconds or other one is megajoule per MVA, that's all. So that is the concept of inertia constant in a power system. So that's very, very important, my dear. So even that means if you have this knowledge, then only you can go for what? The swing equation and all. And another equation also I am going to explain this. Listen. Listen, my dear. See, we have this. We have M is equal to GH divided by pi f. This is in what, my dear? This is nothing but megajoule second per electrical radian. Okay, because pi is there. Another is nothing but GH divided by 180 into F, which is nothing but megajoule second per electrical degree. Is it clear, my dear? Because pi is nothing but in radian. If you want to convert it into degree, you should multiply it with 180 by pi. So this pi and this pi we can cancel, and denominator only 180 will be there. So M is equal to GH by 180 F for megajoule second electrical degree. There are also problems of making, chances of making error, because if the questionnaire gives you in electrical degree, if you substitute it for electrical radian, then things will be changed. That also you should take care of. And if this is nothing but, my dear, base MVA, na? G is nothing but base MVA or rating of the machine. If you divide that base MVA with M, so M by G is nothing but H divided by 180 into F. Okay, which is nothing but moment of inertia with respect to base MVA. That is nothing but, my dear, per unit moment of inertia, which is nothing but H divided by 180 into F. or h divided by pi f. This is in per unit quantity. So you should have the knowledge of three type of moment of inertia, my dear. First one is this one, second one is this one, that is in electrical radian, this is in electrical degree, and this is in per unit. Three you should have the knowledge. These three are very important. Okay, these three are very important. So that's all about the concept of moment of inertia. For next class we will take about, or we will look up about the swing equation. That's more important than every these things, because if you directly go for swing equation, these things will be blank, because you don't know the have knowledge of rotor angle, you don't know about inertia constant, then why, when or how you can go for the swing equation? It will be simply a mug up session for you. That's why I took in detail these all things, right? Okay, thank you so much.